All right, guys, come on in. We are going to play a little game of Kahoot. So if you want to try to get some Kahoot set up while we're waiting for a couple people to enter, I'll get you guys to do that. We will do a little bit of a Kahoot today. So I'll let you guys get that set up, and I'll just get my PowerPoints ready to go for us here while we're waiting for some people to join us. We got a fair bit of you here. We got 8 of you. Hopefully we'll get a couple more. I hope everyone's doing okay. The weather looks a little crappier outside than it has been, but that's all right. We're stuck doing work anyways. Okay, so we will get started. So today we are going to finish off our booklet on the skeletal system. So we'll be done with the skeletal system today. There we go. So we finished with the skeletal system today. We'll do that. There's a booklet on skeletal conditions, which has been added to Google Classroom as well. And when we're done with that, then we'll play a little game. Okay. Hopefully we'll have time to finish the game. We kind of had to go over by 10 minutes for my block 1, but we had a little mishap with the Zoom too. So we should have time to finish it, and we'll see who knows their bones. So just a couple of things. You have a quiz coming up on Monday. That's for the skeletal system. I'll open that from Monday to Wednesday. So that's something to remember. Skeletal system worksheet number 1, I've only got it from about half of you. Skeletal system worksheet number 2, I told you wasn't due until Monday, but I have got that from a small sprinkling of people. So yeah, so without further ado, we will get started here, and we will. So let's go. We want to remember that the osteoclasts, so these guys that are responsible for osteoclasts, these guys are responsible for breaking down bone. That's its own special word called bone resorption. So some places call bone absorption. The fancy word is resorption, but basically it means the breaking down of bone. This is done by the osteoclasts releasing enzymes and releasing acids in order to break down the bone. So osteoclasts break down bone, allow for the bone to lengthen and widen so the individual can grow. Okay. And then what happens, so this breaks it down, and then the osteoblasts come along and they kind of fill that space. And then it has to break down again so it can get longer, and then they fill that space. Notice when we look at these cells, osteoclasts are the ones that have multiple nuclei, and osteoblasts only have a single nuclei. Okay, so our long bones grow and grow and grow until we reach our late teens. Now this usually varies between whether you're a male or a female. In females, it's usually somewhere in grade 8 or 9 that you stop growing. I think I stopped in grade 8. That's not a rule, right? It's usually around that time. It can be grade 10 or 11. And then boys, it's usually grade 12 or, you know, up to about the age of 21, 22. Sometimes a little later, depending again on your genetics. But then it'll stop. So what does that mean when it stops? Well, it stops when your epiphyseal plate hardens. So if we think about our long bone, remember our long bone has the diaphysis, which is the shaft in the middle, and the epiphysis, which are the 2 knobby pieces, right? Well, between the epiphysis and the diaphysis, there's a little bit of cartilage called the epiphyseal cartilage, and that eventually starts to harden and turn into bone. Once that's hardened, it's like the signal where the bone can't elongate anymore. That's when you've stopped growing. And that has to do with puberty, and our puberty hormones have an impact on that. Okay? So if we just take a look at this next image here, so what we see is this is the growth of the long bone. So these happy little guys here, these are the osteoclasts. So basically what they're doing is they're digging out the bone, taking the pieces out that we want to replace. And then we have the osteoblasts dropping off new bits of bone, right? And then what we're looking at here, this is the epiphyseal plate. So growth continues until the epiphyseal plates ossify, which means they turn to bone. Okay, once that happens, we're done. Okay, so like I said, for ladies, for you girls in grade 10, you're probably done growing. And for you guys, probably you're not done growing. You probably have a few years left, okay? And again, all of this depends on some genetics, but we don't continue to grow up into our, late 20s. We're done by usually 21, 22. Okay. So I have a little video here. Now this video is for us to watch about bone repair. So it's how, if we have a break in our bone, how our body works to repair that break. So we'll just quickly watch this here. We'll open that up and then I'll share it with you here. Oops, just have to go back to my share and turn on the sound. Okay, so this will open for us. My house uses
bone fracture healing.
There we go.
There are many different types of bone fractures, such as when a bone is shattered into multiple pieces, a linear fracture down the shaft, a displaced fracture where the bone is misaligned, or an oblique fracture where it has a sloped pattern. A doctor will treat each of these as they see fit. In this video, I'm going to go through a very basic explanation of how the body heals a simple fracture. We're going to start by looking at some bone cells. First, we have osteoblasts, which are next and break down bone tissue. Fibroblasts tissue and fibroblasts.
I'm going to pause it there. So first of all, to take note, this is an incorrect image. Osteoblasts only have a single nuclei. It's the osteoclasts that have multiple nuclei. And then these ones here, the chondroblasts and the fibroblasts, you don't have to know those. They're part of this video, but you're not responsible for knowing those. Okay. All right.
These cells play important roles in the healing process. So let's say a bone breaks. We're going to assume it's well aligned. When the bone breaks, so do the blood vessels running down the bone. So the first thing that's going to happen is bleeding, which will lead to a blood clot being formed. The area will also swell up. Next, phagocytes, which are white blood cells, will come in and help clean up the area by removing dead cells and any germs that may have entered the area. As the blood clot reduces, osteoclasts appear and take care of dead bone fragments. Next, a fibrocartilaginous tissue is formed by the chondroblasts, which holds the broken ends together. The osteoblasts and fibroblasts also begin their work at this time as well. This fibrocartilaginous tissue that is formed is called a soft callus. This soft callus then hardens into a bony callus. This usually results in excessive bone tissue, so the osteoclast reabsorbs some of the extra tissue. When this process is finished, it's usually not 100% perfect, so a slight bump may remain at the spot of the break. The fracture is then healed and healthy. Some things that can impair proper healing include poor blood supply, poor general health can slow the process greatly, infections, age as younger bones heal faster, and the type of break. One thing that you can do to help your body recover from a broken bone is to eat plenty of nutrient-rich foods such as fruits and vegetables. The healing process requires a lot of energy, so increasing food consumption will help, and fruits and vegetables are filled with vitamins, minerals, and antioxidants, which will also aid in recovery. And that be the basics on how the body heals a bone break.
Okay, there's one thing I just wanted to show you here. I was hoping it was in another video I'm going to show you, but it wasn't. We're just going to go back 1 second here. If we look at this part here, so there are situations where people actually want to elongate their bones. So I just read one earlier this morning with someone who is suffering from dwarfism. So she wanted to be taller. So what they do is they immobilize. So they have all these pins that totally immobilize that limb. They break tissue. So they've just cut a gap. So now there's a gap in the bone, okay, kind of like when it's broken. So there's a gap, and then all of this stuff happens, right? We get the cartilage, wouldn't necessarily have the blood there, but they get the cartilage, right? And you need the bone to be close enough together to allow for those cells to do their job. And then slowly little bits of bone grow and connect, and then you cut another part, and then the bone grows and connects. And from what I understand, it's an excruciatingly painful procedure to get done, but people can do it if they want to extend their bones. I don't know if they have the exact same strength, in their bone as someone who would naturally have the bone like that? I don't know the answer to that, but just a little interesting. Fun fact. Okay, so let's go back here. Just do that. We'll go back to the PowerPoint. All right. So bone remodeling. So bone remodeling is something that happens our whole life, okay? Where we're constantly creating and destroying bone. So you guys, for the most part, most of you, maybe not the girls, but the guys are still actively growing. So as you're growing, your bone has to break, right? So the osteoclasts have to come, and then the osteoblasts have to replace that bone to allow for it to grow longer and wider. That's still happening in me in adulthood, right? Even though I'm not growing taller, I still have this remodeling. So the remodeling is continuing on, okay? So for that to happen, old bone is being resorbed, so broken down by osteoclasts. They're the ones with multiple nuclei. And then new bone is constantly being formed by osteoblasts. So those are the bone forming guys. All right, so we're just gonna watch another little video here. We'll only watch the first couple of minutes of it because the rest of it talks a little bit about using stem cells to actually build new bones. So that's sort of what they're looking at being able to do in the future. All right, so just share this with you.
Little Red Riding Hood.
By 2050, there will be more plastic than
Can you grow a human bone outside the human body? The answer may soon be yes. But before we can understand how that's possible, we need to look at how bones grow naturally inside the body. Most bones start in a growing fetus as a soft, flexible cartilage. Bone-forming cells replace the cartilage with a spongy mineral lattice made of elements like calcium and phosphate. This lattice gets harder as osteoblasts, which are specialized bone-forming cells, deposit more mineral, giving bones their strength. While the lattice itself is not made of living cells, networks of blood vessels, nerves, and other living tissues grow through special channels and passages. And over the course of development, a legion of osteoblasts reinforce the skeleton that protects our organs, allows us to move, produces blood cells, and more. But this initial building process alone is not enough to make bones strong and functional. If you took a bone built this way, attached muscles to it, and tried to use it to lift a heavy weight, the bone would probably snap under the strain. This doesn't usually happen to us because our cells are constantly reinforcing and building bone wherever they're used, a principle we refer to as Wolff's Law. However, bone materials are a limited resource, and this new, reinforcing bone can be formed only if there is enough material present. Fortunately, osteoblasts, the builders, have a counterpart called osteoclasts, the recyclers. Osteoclasts break down the unneeded mineral lattice using acids and enzymes so that osteoblasts can then add more material. One of the main reasons astronauts must exercise constantly in orbit is due to the lack of skeletal strain in freefall. As projected by Wolff's Law, that makes osteoclasts more active than osteoblasts, resulting in a loss of bone mass and strength. When bones do break, your body has an amazing ability to reconstruct the injured bone as if the break had never happened. Certain situations.
Okay, so we're going to stop there and go back to PowerPoint here. Okay. Bone remodeling. So what is the point? So the point, part of it, is so our bone has the ability to elongate, right? Because bone can't stretch. We need to put new bone material. And yet if we just pile new bone material on, we would just get it wider in a certain spot. So it has to break down and then be able to elongate that way. To repair damage to the skeleton resulting from repeated stresses, right? So to repair small cracks. over time, little damages happen to our bones. So bone remodeling strengthens our skeleton. And I was just reading something this morning that indicated that our entire skeleton is replaced every 10 years. So for me, I'm 48. My skeleton when I was 38, none of those cells remain in my skeleton today. That's all been replaced, okay? So every 10 years, through this whole process of bone remodeling, those cells are constantly being replaced, okay? Prevent buildup of too much old bones so the bone doesn't become too brittle. And then lastly, if our body is deficient in calcium or phosphorus, this allows for us to have that. So it's a storage spot for calcium and phosphorus. Remodeling releases that back into the blood so we can use those. Now, if we're always deficient in calcium or phosphorus, then our bone tissue won't be able to grow and we'd have quite weak bones, okay? All right, this last video we're not going to watch. It's about 10 minutes long. This is a crash course on the skeletal system. I would strongly recommend it because it's a nice overview of everything we've talked about as far as like the red marrow and the yellow marrow and compact bone tissue and spongy bone tissue. And it talks a little bit about astronauts in space as well. Okay. All right, so we're going to watch one more PowerPoint before we move on to our little game we're going to play. This one I just uploaded today, and this is on conditions. So in our curriculum, we need to think about the different conditions that cause damage to our bones. So we'll just open this up so we can see it here. There. Okay, so we're looking at the skeletal system, but we're just looking specifically at conditions right now. So metabolic bone disease is the first one we're going to talk about. So these are diseases or disorders that involve the bone, lots of bone being lost, or an abnormal formation of the bone. These are typically caused by having too much or too little mineral, so usually our calcium and phosphorus, or not having enough vitamin D. So we want to remember vitamin D is something that our body produces when we're exposed to sunlight, and it helps us with our absorption of calcium, okay? So some of the conditions that fall under this category, one you've probably heard of is osteoporosis. So I put a little image of osteoporosis. So we see a healthy bone and we see the spongy bone tissue, and then we see the big gaps in osteoporosis, right? So not enough calcium. Paget disease is another one. Nutritional rickets, I'm going to talk about a different form of rickets, does the same thing. It leads to some deformation of the bone. And then there's another one called osteitis fibrosis cystica. Okay. We will do a little research project again with musculoskeletal system. Okay, genetics. What do we get from genetics? So a couple of them that I have images of here. So this one is an image of polydactyly. Poly means more than or lots of. Dactyly means fingers or toes. So polydactyly is a condition where we have more than 5 fingers or toes. So it's a dominant condition. So if one parent has it, then it's a 50% shot that one of the kids will get it. So we see the 6 fingers, well, 5 fingers and 1 thumb. But I've seen other images of this where there's 2 thumbs or 1 small little pinky finger that's kind of sticking out but is really not usable, or several big toes. So there's lots of different types of polydactyly. Rickets, so I put that in this category because we can also get rickets as a inherited disease. It's also a dominant disease. Typically, yeah, so it's a dominant disease, more prominent in women. And usually we'll see this bowing. So oftentimes people with rickets will have a bow, and it sometimes can be difficult to walk because the femur sort of bows out, like we see here, okay? There's other ones, osteogenesis imperfecta, achondroplasia. Achondroplasia is a type of dwarfism that is also inherited. And then here's the rickets I was talking about. Structural disorders, so these are disorders to the structure. So one of them here is bunions. So I have bunions, and bunions is typically when your big toe starts to protrude out towards the medial part of your body. Some people have it this way, and some people have bunions going this way. So I had a student last semester who had bunions off of his pinky. It can get quite painful as it rubs against the inside of your shoe or hurts to bend that toe. Unfortunately, to get surgery with this, the recovery time is usually, it's like 3 to 6 months. So it's crazy recovery time. And there's a period of time where you can't be on your feet at all. Cleft palate. So our palate is the roof of our mouth, and we can have a break in that palate. And so this is a couple of images of having a single and then a double cleft palate. Another example of a structural disorder is, there's a few of them with curvatures of the spine. My image here is one of scoliosis. So that's where the spine shifts. So we have this bend, this lateral bend in the spine. Depending on how severe this is, this can make walking and movement very painful or difficult. And then the last one I have here are fractures. So fractures are breaks in the bone. So I have a couple of images of fractures here, right? So these are injuries that we have with the bone. We see the difference between open and closed. Open breaks the skin, closed doesn't. Here we see a green stick fracture. So a green stick fracture is usually, it's like bending a young branch off of a tree. So if you bend an old branch, it'll crack in half and you'll have two pieces. If you bend a young branch, you can actually see the green in the middle, and it sort of bends and kind of tears. This is a young bone fracture, so a younger kid would have this type of fracture. My brother had a green stick fracture, and the bone bent and it twisted and sort of moved in opposite directions. He had to be in traction when he was 2 for like 3 months. It was incredible, the amount of damage that happened to him. The other one I have here is a spiral fracture. So this is where we have this twisting action. So the bone has to kind of be twisted back in order to heal. All right, this video here just talks about the different types of fractures, but I think in order for us to play our game, we need to get started. So if you want to get yourself signed on to Kahoot, and I will get myself going on to Kahoot, and I will share that with you. So here we go. And all right, so there's my Kahoot page. You guys can all see that. If you can't, just send me a chat, and I will put in the chat what the code is for the Kahoot. So it's 578844. So that is the PIN number for the Kahoot. So if you can log into that. All right, game starts in 11 seconds here. That's 6, 7 players. Come on, let's get a couple more in here, guys. 10 seconds left. 7 seconds left. Oh, we got 9 players. Fantastic. Everyone's in. Okay. It'll be a nice competition here. I will post the Kahoot a little later so you can play it on your own as well, just for some more review. Okay, skeletal system review. Name that bone. All right, gotta go fast. And the frontal bone, the one in the front. Good job, you guys. Ooh, a slight lead by Dandy Dingo. True or false? Blood vessels flow through compact bone. True. Compact bone, we want to remember, has the little circles that it forms with the little canals in the middle. Okay, Dandy Dingo, ooh, has a little bit of a lead, 35 points. Okay, name these bones. And the phalanges, our fingers and toes are both called phalanges. Ooh, Quick Dolphin is now in second place. Cute Lion, a streak of 3. Okay, identify this bone. This is the zygomatic. That's our cheekbone. So remember, zygomatic is our cheekbone. Ooh, 3 players lost their answer streak with that one. Ouch, and Cute Lion is in the lead. The main component of yellow marrow is fat. So the yellowy color is the fat, so it's fat. Ooh, Cute Lion maintained their lead, but they're only ahead by 23 points. Tailbone is also called the sacrum, coccyx, patella, cervix. Ooh, the coccyx. Coccyx is our tailbone. That's one to remember. Cute Lion, answer streak of 6. All right. The part of the skeletal system that includes the head, vertebrae, and ribs is called the axial skeleton. The axial. Appendicular is our appendages, our arms and our legs. Okay. Oh, Cute Lion's got about 100-point lead. Name that bone. Patella. The patella is our knee bone. And I've had a couple students that have broken their patella over the years. You are in a nice long cast to be able to stabilize that bone. Ooh, you have to type this one out. How many bones are in an adult human body? Ooh, that's a 9 out of 9. Nice, you guys. Good job. Okay, next. What are these bones? Name these bones. Lumbar vertebrae, our lower back, lumbar, lower. Ooh, Dandy Dingo takes the lead. 10 correct answers in a row. One of the main minerals stored in bone is phosphorus. Yeah, the 2 main ones we talked about, phosphorus and calcium. Phosphorus and calcium. Oh, Bronze New coming up to 3rd place here. Name that bone. That is the sacrum. The sacrum is right above the coccyx. Name that bone. Ah, femur. Everyone knows where their femur is. That's awesome. Ooh, Cute Lions coming into 4th place here. Bone remodeling stops once the epiphyseal plates have hardened. True or false? plates. Remember, my epiphyseal plates have hardened many, many years ago, and I still have bone remodeling going on. And that takes bronze raven to the #1 position. Name that bone. Humerus. So our upper arm bone is called the humerus. Cute lion up to 3rd position. Okay, the rectangle is an image of, so I highlighted something with a rectangle. I'm expecting a 9 out of 9 on this. Are we looking at compact bone or spongy bone? Yes, it looks like a sponge, so we should all be able to identify a spongy bone. Okay, top 4 positions haven't changed. Next we have, name that bone. Sternum. So our breastbone right in the front here is called the sternum. Ooh, top 4 positions stayed where they were again. That's all I can see is the top 4. Name that bone. That is the tibia, otherwise known as our shin bone. Tibia. Ooh, top 4 stayed the same again. We gotta give you guys a bit of a challenge. Oh, Arctic elephant making a comeback. Nice. Name this bone. That is our mandible. Okay, remember the only bone in our facial bones that moves. All right. Name these bones. Are the tarsals. So carpals, you've probably heard of carpal tunnel syndrome. Ooh, cute lines in #2. Carpal tunnel syndrome is about the wrist, right? Carpals. So tarsals have to be our feet. Name that bone. Okay, the maxilla. So the maxilla is up here. And mandible. Okay, oh, our top 4 positions have stayed the same from last time. Cute lion, 9 in a row correct. Name these bones. So it's a group of bones. The neck bones are the cervical vertebrae. Cervical vertebrae. Ooh, cute lion takes the lead. Nice. Fabulous panda, we're at 4th place. Structure labeled C is called the diaphysis. So the shaft part of the long bone is called the diaphysis. Ooh, Dandy Dingo is up to 2nd place. Cute lion has 11 right in a row. Name that bone. Okay, the scapula. So our shoulder blade is our scapula. Oh, our top 4 stayed the same, all within 4,000 points. Name these bones. Metacarpals, metatarsals, tarsals, carpals. Okay, metacarpals. Okay, metacarpals. They're the ones that make up the palm. So carpals are in our hand. Ooh, fabulous panda has now moved their way up to 3rd place. The pelvic bone that is more flared in a female is the ilium, pubis, patella, ischium. The ilium. It's a part that kind of looks like the elephant ears, the ilium. Okay, my top 4 look the same. Fabulous panda, 12 right in a row. Name that bone. Side bone is the parietal bone. Oh, our top 4 stayed where they were. There is very little space between number 1 and number 2 here. The cells responsible for creating new bone are the... Okay, we just watched some videos on this. Let's see how well you remember. Osteoblasts. The osteoclasts break down bone. The osteoblasts. Ooh. Dandy Dingo, back up in the lead here. What's this bone? Name that bone. This is the radius. You want to remember the radius runs along where the thumb is. The radius. Oh, our top 4 stayed where they were. Okay. Fabulous panda, lots in a row here. Cranium is responsible for protecting the... The brain is protected by the cranium. Okay, top 4 stayed where they were. Well, 2 and 3 have pretty close to one another here. True or false? Blood cells are produced in the yellow marrow. True or false? False. Blood cells are produced in the red marrow. Good job, you guys. Ooh, Fabulous Panda is in 2nd place. Arctic Elephant has 3 in a row. Name that bone. This is the bone that I broke many, many years ago. The fibula. Fibula. So that's the little bone. The tibia is the big bone in the lower leg. Okay, Dandy Dingo is still in 1st place here. In the long bones, yellow marrow is found in the epiphysis, compact bone, cartilage, medullary cavity. Medullary cavity. So not the epiphysis. The yellow marrow is in the middle part. The red marrow tends to be in the epiphysis. So Dandy Dingo in the 1st place still. The posterior end of the ribs are connected to the sternum, sacrum, thoracic vertebrae, lumbar vertebrae. Of course, this means you know the term posterior, which you should all know from our 1st module. Sternum is anterior, that's the front of us. Posterior, remember posterior where bum is, posterior. Fabulous Panda, 20 answers in a row that are correct. Soft spot in a baby's skull are called fontanelles, fibula, fossa, foramen. Fontanelles, nice. 8 out of 8. Good job, you guys. And our top 4 stayed where they were. Fabulous Panda, 21 right in a row. Which of the following is an example of a short bone? So think of all the short bones. Which one fits in that category? Carpals, maxilla, phalanges, sternum. Carpals, it's the ones in our wrist. Remember, they're kind of the cube-shaped bones. Okay, top 4 have stayed the same here. The ribs that do not have anterior attachments are the floating ribs, disarticulated ribs, false ribs, true ribs. They're the floating ones. They're attached out at the vertebrae, but they're not attached in the front. Okay, fabulous panda, 23 in a row correct. Dandy Dingo is winning. Name that bone. The coccyx, which is our tailbone. So the coccyx is our tailbone. All right, next one. Name that bone. What are we looking at here? Ulna. The ulna runs where our pinky finger is. The ulna. Ooh, cute lion is now in 2nd place. Nice. All right, the raised area in bones are collectively called foramen, elevations, depressions, projections. They're called projections. Projections. Those are the raised areas. Okay, our top 4 stayed the same. And we've got 3 more to go, guys. Which of the following is an example of a flat bone? Carpal, ulna, mandible, sternum. Our sternum is a flat bone, nice and flat as our breastbone here. Okay, top 4 stayed the same. 2 more to go. Name that bone. Awesome, 8 out of 8. That's the clavicle, most broken bone in the body. All right. And one more, last one. The picture of the osteoclast is image A, image B, or image C. That is image A because there are so many nuclei. All right, that is it, guys. So we have Dandy Dingo, who won 1st place, Fabulous Panda, who got 2nd place, and Cute Lion, who got 3rd place. All right, so that's it for our game today. That's it for our lesson. We made it right to the exact time I wanted to be done. So don't forget, you have a quiz opens on Monday through Wednesday. Skeletal System Review 1 is overdue. Skeletal System 2 is due Monday, but honestly, if you sit down and do it, it'll take you probably about 15 minutes or less, maybe even 10. Okay? And that's it. On Monday, we start muscular system. So we learn about the muscles. So unless you have any questions, that's all I have for you today, and have a wonderful weekend. We'll see you Monday.